Hello everyone. In this session, we will take more problems on permutation. Whatever problems we have taken by now, to get more clarity or more hold on the topic, this session was required. So let us start with more illustrations on permutations. Now my first illustration is NP4 is given to me as 2100, NP3 is given to me as 30, and we are asked to find value of n. 4 options are given and we have to pick up the correct one. Now when I look at NP4 equal to 2100 and NP3 equal to 30, now NP4 general formula you can use, NP3 general formula you can use, and we have to get n. Actual expression for NP4 would be n factorial upon n minus 4 factorial. For NP3 it would be n factorial upon n minus 3 factorial. You have just two equations actually, correct? And we have to get n. It looks tedious, but use little intelligence and divide one by other, right? And by dividing, what happens? Actually, NPR formula you know, NPR minus formula you know, you substitute formulae actually and simplify. You will get answer as n minus r plus 1. If you want to remember this as a formula, choice is entirely yours. But actually, it doesn't take fraction of second to write even that n minus r plus 1. So using that, I'm writing here n minus 4 plus 1. That means now n minus 4 plus 1 is going to be nothing but 2100 upon 30, correct? Now simplify and get your final n as 73. So my correct answer is C, correct? Now this question was only for revising formula of NPR, right? So let us move from here to the next one. And my second illustration is how many different alphanumeric codes can be made from AXY, from AXZ and 7 and 9. And condition is using any number of characters. When I say characters, means numbers as well as those AXZ. Now, condition is you can use any number. So choice is entirely yours. There are 5 such options, AXZ and 7 and 9. Correct? Now, out of these 5, you can use as many as you wish. So, any number, that part must take your attention. When you read question, please read carefully. Most of the competitive examination questions play with such ideas that if you do not read question carefully and with your own like intuition, what you are writing answer, one of the options would surely be there and you would end up making mess there. So please read question carefully. Any number, that particular part must take your attention. Okay. So different codes can be made in how many ways? You choose only one at a time, or you choose 2, you choose 3, and then make the codes. So my correct answer should be, the required number should be 5p1 plus 5p2 plus 5p3 plus 5p4 plus 5p5. Why I'm saying so? 5p1 means what? You arrange one only at a time. You take one of the options and arrange it. 5p2 means what? You are taken some 2. It could be one number and one letter, or it could be both the letters, like that. 5p3 means what? You are taking 3. It could be all 3 letters, or it could be one letter, 2 digits, various options, whatever you have. So that all come under 5p3. So 5p1 plus 5p2 plus 5p3 plus 5p4 plus 5p5. That should be your final answer. You actually write values for 5p1, 5p2. Evaluate and write. That is what I have done here. So my final answer would be from here as 325. So my correct option is B. Here what we did is, I wanted to take your attention to actually reading question. You should read carefully, then you can answer carefully. So here main crux was any number of characters. Let us move from here to the next one. And my next illustration is 20 persons attend a party, including the host. How can these people be made to sit around a table such that 2 particular people want to sit next to host? So picture is something like, I draw the picture. And picture is something like that a round table, there is a place for host and 2 particular people sit next to that host. Now, how host chooses his chair? Understand one thing forever, that unless host takes his chair, no orientation is given. Means once host takes his place, who is on his right, who is on his left, that all will get meaning. But when host goes and takes his chair, in how many ways he can get? He can go and sit on any chair, right? So realize this, that the host takes his chair only in one way. Till then, there is no orientation. Okay? And next is what? That once host is fixed, those two particular people, those who want to sit next to him, they can choose their chairs in two ways, right? So that arrangement of two particular people will go in two factorial ways. Now, how many are remaining people? Remaining people would be 20 minus 3, so 17. So now these 17 people are to be arranged. Understand one thing. Now, the moment that host has taken his place, two particular people also have taken their places. Remaining 17 people, when you are asking to sit, when they sit, it would be treated not as circular arrangement. It becomes now a case of simply arranging 17 people in 17 places. So that is 17 factorial ways. This is no more circular permutation. So my final answer should be, yes, what? 17 factorial into 2 factorial. Host takes his chair in one way only. So correct answer is option A. Right? Let us move to the next one. Fourth one. And fourth illustration is, how many numbers can be formed from the digits 1, 2, 2, 5 and 6. And condition is which are greater than 50,000. And then 4 options are given. Mind you please, when that condition starts coming in the problem, then it starts giving problem also. So initial problems were very straightforward of multiplication principle or addition principle, or maybe permutation, I would say. Very straight questions were there, which were based on your theorems. Now this session, what questions I am taking, you must have observed, all those questions are not straight application of those theorems, correct? So here condition is more than 50,000. Whatever number you are making, that should be more than 50,000. Okay. Greater than 50,000 means there is some restriction in place of 10,000. First place, I have shown there 5 places. The leftmost is that 10,000 place. It can be filled only by 5 or 6. So only 2 options are there for the first place, right? And what about remaining places? Remaining places, actually, if you go to see, now would be filled by 1, 2, 2 and one of those 5 or 6, whichever is the left out one. So now we have 4 options for next 4 places. So my answer could have been simply 4 factorial, provided you were having distinct digits. Here that is not the case. They are not distinct. There are 2 2s, correct? So we need to divide by 2 factorial also. And 4 factorial upon 2 factorial gives you number of what? Of arranging rest 4 places, correct? So the required number would be 2 into 4 factorial upon 2 factorial, which on simplification would be simply 4 factorial, and answer is 24. So my correct option is A. Right? So in this session, we had some questions on permutations, which were not straight away applications of theorems. Somewhere you have to think, you have to be alert and then answer. Again, in next session, I will come with something new. Hope you have enjoyed the session. If you have liked the video, please click on this side. And if you want to place an order for the book, click on this side. Thank you.